Orthotic treatment in case of weak dorsiflexors and plantar flexors. Why the NEURO SWING is state-of-the-art in neuroorthotics. This is the third video in a 4-part series of educational videos. It is advisable to watch all 4 videos in order to fully understand the context. Chapter 3.1. Why pre-compressed spring units are state-of-the-art. In case of weak plantar flexors, an efficient FIOR consists of a foot piece that is rigid between the heel and the axis of rotation of the toes, a rigid anterior shell, and a mechanical ankle joint with dorsiflexion stop. When leaning against the anterior shell, the dorsiflexion stop activates the forefoot lever, counteracting the ground reaction force. This creates a resistance, which enables a secure stance. The resistance created by a dorsiflexion stop is equivalent to a force acting on the tibia. This force enables a secure stance. When leaning backwards, a plantar flexion stop helps to balance the body's center of gravity in the most secure position. However, it is not essential. A static dorsiflexion stop or a rigid FIOR provides resistance by completely blocking the rotation of the ankle joint. A dynamic dorsiflexion stop is a better option, because it provides resistance while still allowing the ankle joint to rotate. In case of weak plantar flexors, to ensure the most secure stance, the dynamic dorsiflexion stop must have the following qualities. When standing still, at the most stable inclination angle of 8 degrees, there must be no force acting on the tibia that could push the knee into hyperextension. Once a stable inclination angle of 8 degrees is exceeded, the resistance force must take effect immediately and be strong enough to hold the body weight across the entire supportive area. The ankle joint should be able to rotate against the resistance to ensure a physiological gait. Claim 1. Regular springs cannot provide enough security. Claim 2. Compressed springs reduce mobility and do not increase security. Claim 3. Posterior leaf spring FIORs or spiral orthoses are similar to orthoses with regular springs or compressed springs, depending on how rigid they are constructed. Why? Claim 1. An FIOR with a dynamic dorsiflexion stop using regular springs cannot provide enough security. In most cases, regular springs used in a dynamic dorsiflexion stop are too weak and do not provide immediate resistance when the set inclination angle of 8 degrees is exceeded. It is only possible to stand using regular springs because a fully compressed spring acts as a rigid stop, providing enough resistance to prevent falling. However, it is common for springs that are often fully compressed to fail prematurely. Therefore, it is not a state-of-the-art treatment. Despite allowing some flexibility of the ankle joint, regular springs do not allow for stable standing and can fail prematurely. Claim 2. An FIOR with dynamic plantarflexion and dorsiflexion stops using regular compressed springs reduces mobility and does not increase security. Due to the lack of spring force of regular springs, it is common practice to press opposing springs against each other. Although this increases the rigidity of the springs, it restricts their range of motion. Compressing the springs only slightly increases the resistance from an inclination angle of approximately 8 degrees, however, standing stability is not improved. The feeling of increased stability is mostly due to the springs reaching full compression earlier. An FIOR with a dynamic dorsiflexion stop with a regular spring of any strength is not the optimal solution. Claim 3. Posterior leaf spring AFOs, spiral orthoses or other AFOs without mechanical joints act similarly to AFOs with mechanical ankle joints with regular springs or compressed springs. They generate resistance by flexing and can be made more rigid by restricting mobility. As the resistance force is similar to that of regular springs, it still cannot provide enough security when standing. Most importantly, there is no rigid stop to prevent leaning past the supportive area, which can lead to falling. Such an AFO can be dangerous and should not be used in case of weak plantar flexors. Claim 4. Interchangeable precompressed spring units are state-of-the-art. Why? The best solution is a system ankle joint with dynamic plantar and dorsiflexion stops with precompressed spring units, such as the NEURO SWING. This joint option offers numerous advantages. The precompressed spring units are strong enough to counteract the body weight. If a stable inclination angle of 8 degrees is exceeded, precompressed spring units provide stability at any inclination angle, unlike regular springs. In addition, different springs can be used for the dorsi and plantar flexion stop to fully adapt the system ankle joint to the patient and maximize security. At the same time, a wider range of motion of the ankle joint is achieved, which helps promote a natural gait and can counteract muscle fatigue. An AFO with a dynamic dorsiflexion stop using a precompressed spring unit is the ideal solution. Chapter 3.2. Function of an AFO with a NEURO SWING system ankle joint. When standing with an AFO with a NEURO SWING system ankle joint, its dynamic dorsi and plantar flexion stops using precompressed spring units activate the natural forefoot lever and fully counteract the ground reaction force. This helps to maintain the body's center of gravity in a stable balance, ideally above the middle of the supportive area. The use of the precompressed spring units ensures secure standing while maintaining a physiological knee joint angle, without unwanted additional pressure to the lower leg and a hyperextension of the knee. This allows the body's center of gravity to be shifted forward over the supportive area. The NEURO SWING is equipped with interchangeable precompressed spring units with different spring forces. With the NEURO SWING system ankle joint, the resistance can be adjusted through interchangeable precompressed spring units, in a way that allows standing in a stable balance, without additional walking aids. The angle at which the spring unit starts providing its specific resistance can easily be adjusted by 2 alignment screws. The spring force of the chosen spring unit will not be changed. This allows for the most stable position to ensure a secure stance.